You know, what does a painting, a floor plan, and even a page in a book all have in common? Well, they all take up a certain amount of space. And that space has a name. It's called area. And today, we're going to unlock its secrets.
Just look at this incredible Rangoli art. It's absolutely beautiful, right? Artists make these stunning designs by filling in these really intricate patterns with colorful powder. The whole art form is literally about filling the space inside different shapes.
But that gets you thinking, doesn't it? How would you figure out exactly how much powder you'd need? How could you measure that flat space precisely to know if one design is bigger than another? Well, that's the challenge we are taking on right now. Ready to jump in? Awesome. Here's our plan. We'll start with the basics, what is area, then we'll get into the super useful rectangle rule. We'll see what happens when we slice shapes in half, and we'll finally clear up the difference between area and perimeter. Then we get to the really fun stuff, rearranging tricky shapes and seeing how area pops up all over the real world.
Okay, so let's start at the very beginning. What exactly is area? With any kind of measurement, we need a standard unit to work with. And for area, our fundamental building block is actually super simple.
It's called the unit square. Just picture a perfect little square where each side is exactly 1 unit long. Could be 1 centimeter, 1 inch, whatever. The area of any shape is just the number of these little squares you can fit inside it. It's as simple as that.
All right, now that we have our basic building block, let's put it to use, starting with pretty much the simplest shape out there, the good old rectangle. Now, with a rectangle, you don't actually have to sit there and count every single square one by one. There's a fantastic shortcut. You just multiply the number of squares along its length by the number of squares along its width. That's it.
So, for example, a rectangle that's 7 centimeters by 4 centimeters, well, that can fit 28 of those little 1 centimeter squares. But look at this other one. A longer, thinner rectangle that's 8 by 3 centimeters, it only fits 24. So even though it's technically longer, it actually has a smaller area. It holds less space. Kind of wild, right?
So what happens when we start cutting up our shapes? This is where things get really interesting, and it's the key to figuring out the area of a triangle.
I want you to imagine taking any rectangle, okay? And just slice it right down the diagonal, from one corner to the opposite corner. What do you end up with? Boom! 2 identical triangles. Each one is a perfect half of the rectangle we started with.
So it follows, right? If the area of the whole rectangle is its base, that's the bottom side, times its height, then the area of one of those triangles has to be exactly half of that. So it's 1/2 times the base times the height. Totally makes sense. Okay, let's tackle something that trips a lot of people up. Think about a field. The area is all the space inside the field, right? Where you'd plant your corn. The perimeter, that's just the fence that goes all the way around the outside. They're 2 completely different things.
So, let me ask you a question. If you have a specific amount of fencing, let's say 24 meters of it, do you always enclose the same amount of space no matter what shape you build? Take a second and think about it. Does the same perimeter always mean the same area? And the answer is a huge no. Absolutely not. Check this out. A long, skinny rectangle that's 10 by 2 has a perimeter of 24 and an area of 20. But a 6 by 6 square also has a perimeter of 24, and its area is a whopping 36. That is almost double the space. Same amount of fence, but wildly different areas.
This is where we get to the really cool part. We can basically become shapeshifters, rearranging these complex-looking shapes into simple ones so we can easily figure out their area. So take a look at this parallelogram. You know, that kind of slanted rectangle? It looks a little tricky to measure, doesn't it? But what if I told you we could turn it into a simple rectangle without changing its area one bit? Any ideas how we could do that? Okay, here's the magic trick. We're going to slice off that little triangular piece from one end. Now, watch carefully. We're just going to slide it over to the other side and fit it right into that empty space. And there it is. It's a perfect rectangle. See? We didn't add anything, we didn't take anything away, we just rearranged the space. So the area of a parallelogram is simply its base times its height, just like the rectangle it was disguised as all along.
And that one idea holds the secret to unlocking the area of pretty much any shape, any polygon, any straight-sided shape, no matter how weird and complicated it looks, can be broken down into a bunch of triangles.
You just find the area of each little triangle, add them all up, and bam, you've got the total area. It's an incredibly powerful idea.
So all this is pretty cool, but you might be sitting there thinking, okay, but when am I ever going to use this? Well, the truth is, area is all around you every single day. Let's take a look.
We use different units of area for different jobs, right? We might use tiny square centimeters for something small, like a postage stamp. We use square feet for figuring out the carpet for a room. And for really big things, like a national park, we use massive units like acres or even square kilometers.
And just to give you a sense of scale, here's a fun fact for you. A single acre is over 43,000 square feet. That's a lot of those 1 foot by 1 foot squares. To put it in perspective, it's almost the size of an entire American football field. And all these different measurement systems, they can talk to each other. It's kind of like translating between languages. So 1 square inch in the US system is the same amount of space as about 6.45 square centimeters in the metric system. It's all just different ways of counting those same little unit squares.
So I'm going to leave you with a final challenge. Just look around you for a second. The floor of the room you're in right now, it has an area. Can you guess what it is? How many of those 1 foot by 1 foot squares do you think would fit on it? I promise, once you start seeing the world in terms of area, you will never look at space the same way again. Go on, give it a try.